this optimization out of my head.
So, this first question, in a park, the map of all possible routes is located directly at the entrance. The printed region with color-coded routes makes up 150 square inches. There are 1-inch borders on the sides and the top, with a 2-inch margin at the bottom. What are the dimensions that would minimize the piece of wallboard that can be used for the map? So, basically this is just asking the area with the margin, so you have to find the area, which is width times height. The width is just x plus 2 because the margins are 1 and 1, so you add those together and it's x plus 2. The height is just 150 over x because width times height is the area. So you do the overall minus the width, and that's 150 over x because it's 150 square inches. And then you do plus 3 because the margins are 2 and 1. Then you have, once you multiply that out, you get x plus 2, 150 over x plus 3. Once you multiply that out, you get 156 plus 3x plus 300 over x. You do the derivative of that, and you get 3 minus 300 over x squared. And you're doing the derivatives because in order to find the mins and the maxes, you have to get to the second derivative, because when it goes from positive to negative, that's how you find, or negative to positive, that's how you find mins and maxes. So the first derivative is 3 minus 300 over x squared. So once you have that, you can set it equal to 0, and then you're left with 3x squared minus 300. You can factor out a 3, you're left with 3x squared minus 100 in parentheses. And then you can take that and make it x plus 10, x minus 10. So the answer for the first derivative for both of them is negative 10 and 10. And since you can't have a negative area, it's just 10. So you plug 10 into the second derivative, and that gives you 0.6. So the answer is the height equals 18 and the width equals 12, because you plug 10 into 10 plus 2 is just, 10 plus 2 is just 12, and then you plug it into the height equation, and those are your two answers. But since the first derivative of 10 equals 0, the second derivative of 10 is greater than 0, that means that 10 as the area is the minimum. So this question is, analyze the function f of x equals 9 minus x squared. Let g of x equal the shaded area of the isosceles trapezoid that has 2 vertices on the x-axis and 2 vertices on the graph of f, as shown. This being the graph. So find the maximum value of t of x from the interval 0 to 3. The area of any trapezoid is 1/2 parentheses base 1 plus base 2 times height, and in this case the base 1 is 6 because the roots of it are negative 3 and 3, so between that is 6. And then at any point on this graph, the points are just x and then f of x. So 2x would give you the distance between both of these points on the x-axis. So then the height would be 9 minus x squared, because that's just the graph of the function, and that'll tell you the height at any given x. So when you multiply all those out, or when you do for the area, you get 27 plus 9x minus 3x squared minus x cubed. So then you take the derivative of that, and you get 9 minus 6x minus 3x squared. And that leaves you with 3, and then in parentheses x squared plus 2x minus 3, which you set equal to 0, so you can get the roots. And then you do negative 3, you change the x squared plus 2x minus 3 into x plus 3, x minus 1, so you can get the roots of that, and therefore your answer. And then you're left with negative 3 and 1, and since it's from the interval of 0 to 3, the only possible answer is 1. So that is your answer for x for the max. So this one, triangle ABC has a side length b equals 10 and c equals 12. What is the measure of angle A that will maximize the area of the triangle? So for the area, you would have to do 1/2 times b times c times the sine of a, because you don't know the side length of a. And that leaves you with the area equal to 60 sine a. You then have to take the derivative of that so that you can get the maximum. And that gives you, once you take the derivative of 60 sine a, you're left with 60 cosine a. And you set that to 0 so that you can get the maximum. And basically then you have to figure out what makes cosine of a 0, which is pi over 2 and 3 pi over 2. But for this question, we just have to work with pi over 2. So once you have that, you take the second derivative, which ends up being negative 60 sine a. And since we already have the pi over 2, you plug the pi over 2 into negative 60 sine a. And since the second derivative of that is less than 0, you know that pi over 2 is the max for that side length. I'm about to return to the gym. Hopefully this optimization, getting clear from my head, is going to bring my talent back, but that's to be seen.
The taping later.
I recommend optimization to any athlete who wants to improve their game. For me, it made a world of difference, so everybody should take the time.